Ever wonder what gives Python its superpowers in the world of data, machine learning, and all that amazing scientific research? Well, a lot of the time, the answer boils down to one single, incredibly important library. Today, we're going to pull back the curtain on Numpy, the package that is, quite literally, the bedrock of modern data science.
But to really get why Numpy is such a big deal, we first need to understand the problem it was created to solve. And believe it or not, it's a surprising weakness that was hiding inside Python all along.
So here's the big question, right? Python is famous for being easy to use, super flexible, it's powerful. So why does it kind of hit a wall when you ask it to chew on massive amounts of numbers? What's going on under the hood?
And this slide right here, this explains everything. On the left, you've got your standard Python list. Its greatest strength is its flexibility. You can toss in numbers, words, whatever you want. But that flexibility comes with a huge price tag. It's slow. Now look to the right. A Numpy array has one simple, strict rule. Everything inside must be the same type. And that one constraint, that is the secret sauce that makes it unbelievably fast for math.
All right, so we've seen the problem. It's time to meet the solution. Let me introduce you to the hero of high-performance computing in Python, Numpy.
And here it is. Numpy is a library that was custom-built for one thing, blazing fast array computing. And when I say fast, I mean seriously fast. We're talking performance that can go toe-to-toe with super-optimized languages like C and Fortran, but you get to keep all the beautiful simplicity of writing in Python. It's the best of both worlds.
But its influence doesn't stop there. Not even close. Numpy is the foundation that the entire Python data science world is built on. You know all the big names, right? Pandas for handling data, SciPy for complex science, scikit-learn for machine learning. Well, they are all built directly on top of Numpy. Without it, the data science landscape we know today just wouldn't exist.
So, what's the secret? What gives Numpy all this power? To understand that, we need to meet the core component, the absolute heart of Numpy, the mighty ND array.
So this is it, the ND array, which just stands for n-dimensional array. This is the data structure that makes all the magic happen. The best way to think of it is as a hyper-efficient, perfectly organized grid for your numbers. And because every single thing in that grid is the same type, Numpy can perform operations on the whole thing at once instead of having to go one by one.
You know, every end array has a few key properties that tell you everything you need to know about it. The D type is just what kind of numbers are in here, integers, decimals. Then you've got rank, which is simply the number of dimensions. The shape tells you how big each of those dimensions is, like say a grid with 3 rows and 4 columns. And finally, in the world of Numpy, dimensions are just called axes.
This little table makes that whole idea of axes and shape super clear. What we're looking at here is a 2D array, basically a matrix. Axis 0, you can see, runs down and it has a length of 3. Axis 1 runs across and it has a length of 4. So the shape of this array, it's just 3, 4. Understanding this structure is absolutely key to unlocking Numpy's power.
And just so you know the lingo, a simple one-dimensional array is called a vector. A two-dimensional one, like we just saw, is a matrix. And anything with 3 or more dimensions, you'll hear that called a tensor, a word that pops up all the time in machine learning.
Okay, enough of the theory. Let's get to the really fun part and see how all this stuff translates into some incredibly powerful and yet surprisingly simple real-world code.
This is where your mind kind of gets blown, especially if you're used to standard Python. If you wanted to add 2 regular lists together, you'd have to write a loop to go through each element. With Numpy, nope. You just use a plus sign, done. Want to multiply every single number in an array by 10? You just write times 10. It's that easy.
But wait, it gets even cooler. There's this feature called broadcasting, and honestly, it's one of Numpy's most powerful capabilities. It's what allows Numpy to intelligently figure out how to do math between arrays that don't even have the same shape. It feels like magic, but it follows a really clever set of rules.
So let's break down how this magic actually works. It's actually pretty intuitive. First, let's say we want to add the number 5 to an entire array. In step 2, Numpy sees this and virtually stretches or broadcasts that 5 to match the shape of the bigger array. And then finally, it just does the simple element-by-element addition. This all happens automatically behind the scenes, and it's ridiculously efficient.
Okay, so fast arrays, broadcasting, it's all very cool. But why does any of this really matter? How does this stuff make Numpy the absolute foundation of data science?
Well, the thing is, fields like machine learning aren't just about code. They are built on a mountain of mathematics. To train an AI model, you are constantly running these complex formulas over and over and over to see how well it's doing and how to make it better. In this world, speed isn't a luxury, it's everything.
And here's a perfect example of what I'm talking about. This formula is for mean squared error, a really common way to grade a model's performance. Just look at it. You can almost feel how slow and clunky it would be to write this out with traditional loops in Python.
And here it is. This is the aha moment. With Numpy, that intimidating-looking formula turns into a few clean, readable, and lightning-fast lines of code. You can subtract two whole arrays, square the result, and take the average, all with simple, intuitive code. That right there is why Numpy is king.
So in the end, it really all comes back to this one powerful concept, that efficient end array. This single data structure is the computational engine running under the hood of countless fields, from science and engineering to data science and the AI that's changing our world.
It's an unbelievably powerful tool that puts high-performance computing right at your fingertips. So really, the only question left to ask is, now that you've seen what it can do, what amazing problems are you going to solve with it?